Hello friends, welcome to this Shardeum workshop of Ur-Hackathon. Today we have Sandeepan. Sandeepan was the lead developer at Shardeum, so he will be taking from here. Sandeepan, over to you.
Yeah, thanks a lot. Hey, hi everyone. Very excited for this hackathon. Today we are going to learn a little bit about Shardeum and what you can build on top of it. So let's get started. Let me just quickly share my screen and take this forward. I hope my presentation is visible. Uh, Let me know if it's not. So
Yes,
yeah,
it is visible.
awesome. So yeah, today we are going to start a basic introduction about Shardeum. We are going to learn how to build scalable decentralized applications on top of Shardeum, layer 1 EVM blockchain. I'm Sandeepan Kundu. I'm a DevRel engineer at Shardeum. Um, let's start with the problem statement first. So what are the problem statements the current blockchains face? Is on scalability. So the existing blockchains don't scale on the level of that it needs to dynamically. So for example, if you see like the for this slide, it's a very simple, just a diagram. On the x-axis, you have demand. On the y-axis, you have user experience. So initially, you will see when the demand is low and there are less number of transactions happening on a particular blockchain, like the user experience is great, like the transaction fees are low, like the transactions are going through easily. There is no peak jump in gas prices. So the initially when the demand is low, the user experiences is good. And now as the demand expands, the blockchain tries to scale, but it hits a certain peak point, after which it's not able to scale any further, no matter how much the demand is. So like, and as blockchains gain more popularity, the more and more there's more and more, like there's limited amount of block space. So there are more and more transactions happening, and thus resulting in high gas prices. And then after that certain peak point, then as the demand continuously keeps growing, the user experience continuously starts dropping. Transactions getting expensive, transactions not getting included into the blockchain. Then this is like bad user experience, and at the end, that whole experience of building on top of Web3 and using Web3 applications, that doesn't seems right anymore after this point. Then when the common users start feeling pain for using even basic of transaction, for even sending directly sending one wallet to another. So that's the scenario right now in the blockchain scalability space, that existing blockchains don't scale as the demand grows. And there has been multiple approaches on how you can solve this scalability issue. For Shardeum is an EVM-based layer 1 that scales linearly with dynamic state sharding. Now, there's a lot of words in this statement, and we are going to break down each one of those words, and we are going to learn like what those means and why should we even care about it. So the number one like feature which Shardeum brings onto the table is that from what its name is derived from, the technology of sharding. So sharding is basically imagine there's a blockchain network, and for most of the blockchain networks, each of the node needs to validate their transactions. So if you say that I want to send this like $10 from A to B, that transaction needs to be validated by each one of the nodes present in the network. Thus, the network is dependent. The network is dependent on just speed of what any one node is, because everyone is doing the same redundant work. Every node is jumping onto the network and validating that same transaction, and only after everyone comes into the conclusion, or in some cases a majority comes into the conclusion, then that transaction is processed successfully. But in sharding is a technology in which instead of everyone, each of the nodes coming into the consensus, we divide the blockchain into multiple smaller shards, and those are basically group of validators, but those are separate entity, and each of the shard has their own capability of validating a transaction. So from imagine in a case in a supermarket you're going, in which there is only one cashier, and then one cashier, and there's a separate line of people who are waiting to use that service or use that cashier service. In case of Shardium, instead of just one cashier, there are 15 other cashiers who are like checking you out, checking all your transactions at the same time. So instead of just one by one, you're having 15 people can go through once again. So it's similar to that, and that's the benefit of dividing the blockchain into shards, and that's the use of dynamic state sharding. We're going to learn a little bit about what dynamic state sharding is in the in some of the future slides, but yeah, that's the overall basic idea. And then the TPS per node, transactions per second, is a very crucial metric for any blockchain. Like if you want a blockchain to be widely adopted, it needs to be like as good as the current financial systems. For example, Visa processes 300,000 transactions per second, like more than that. So if we are aiming for blockchain to gain mass adoption, we need that TPS per node to be like matching those or even exceeding those limits for daily usability. So dynamic state sharding enables Shardeums to increase its TPS capacity, so that with with the addition of every new validator, the network keeps increasing its TPS. So, and this is also what one of the part dynamic. Why is it dynamic? This is like much more explained in depth in the next some of the next slides. But why we need the increase its TPS capacity with each validator, and how is it dynamic? We are going to get into much in depth with that. But from this chart, you can see that with every additional nodes, we are getting that linear scalability. So if there is 10 nodes, then we have 10 TPS. If there is 100 nodes, we have 100 TPS. And this is important. Like TPS shouldn't just be limited because there is a fixed number of validators. Like that's the whole concept of where sharding comes in. And Shardeum is decentralized and secure. Shardeum uses a combination of proof of stake and proof of quorum consensus. And the consensus architecture is very light. The requirements to run a node is very low. Hardware requirements are needed, and the node rotation in Shardeum maintains the decentralization and the security of the network. And again, you would see like you come across node rotation. So dynamic TPS per node, linear scalability, and node rotation. All of these are linked with each other. And as we go forward into the workshop, we're going to learn how each one of those plays together and forms that final conclusion. So let's get started with the dynamic state sharding. So in this case, you can see that there are addresses and there is balances. So this address has 16 SHM. SHM is the native token to the Shardeum blockchain. And this address has this many SHM and respective. So in the case of this is a case of a general blockchain. Each of the address has a particular balance, and at least most of the nodes come to the conclusion that yes, indeed, this address has this much amount of token of a particular sort. But in case of dynamic state sharding, what we have is that each of those shards maintains a specific record of a particular address, and thus, and instead of just the entire validator network, instead of the entire network coming to the conclusion, only a couple of shards or maybe a group of shards needs to keep a track of that address. Again, let's get into a little bit in depth here. In this slide, you will see that there are multiple. So each one of these machines represent a node, and you would see that machines are grouped together. This is one group, group of machines, for example, and thus one group of nodes. One group of nodes, we can call it as one shard. So this is one shard. This is another shard. This is another shard. So there are multiple shards represented here. And for this particular first shard, this is covering a range of addresses. This is covering this address. This is covering this address, and this is covering this address. So instead of all the shard needs to be covering all the addresses, we are dividing the blockchain again. So now we are like already removing the redundancy part of everyone needs to keep track of everything. Everyone does it, right? So for this shard only cares about this, and this address. But also, we don't want that for a particular, if a group of validator leave, or a shard, or there's node rotation, then that one of the shards, like they move from the network, that your data is lost. Like you don't want that. So there is some other validators and other shards which are also keeping track. For example, you see that this shard is also keeping track of this particular address. So in case this shard is unavailable or it's not in the network currently, then like you still can retrieve and interact with this address. So there are other addresses also, but the only point here is that not everyone is connected with all the charts, right? You see, like not everyone. So it's this shard is not connected with all of the addresses. Thus, like the breaking of the blockchain into multiple shards helps in its scalability. And this how many shards or how many nodes come to the notation, like that is something which is featured by another, like which is covered by another feature called auto scaling. But this is the basic overall idea of what dynamic state sharding is. This was a very basic explanation, and this can sound a bit confusing in the beginning, but I will also share our documentation and our blog, in which if you go through this concept a little bit, like it's not that difficult. The only thing you need to care about is that the blockchain is divided into multiple shards. The shards the shards consist of multiple nodes. The nodes are inter-rotated amongst each other so that we maintain decentralization. And each of the shard is only tracking a group, a separate set of addresses. And there are some overlap which are meant to happen so that you don't lose access to the data at any given point of time. That's all you need to take from this slide. Now coming to the feature of in some of the previous slides I said, right, dynamic state sharding, TPS per node, and linear scalability, and decentralization and security because of node rotation. That's what we are coming with the auto scaling feature in Shardeum. The Shardeum blockchain is designed in a way that the blockchain is smart enough to scale itself up or down according to the, wait, did I receive any message? Okay, the questions. Cool. Yeah, I will get back to the questions once I finish the presentation. But yeah, like on the auto scaling feature, that like once so in this case, you see all the black dots. The Shardeum blockchain has two sets of validators: active validators and standby validators. So there's a group of active validators which is actively making the transactions and validating those transactions. So for example, let's assume there are 750 active validators. Right now, the Shardeum blockchain has 750 TPS. We're assuming that. And assuming that there are still other standby validators which are waiting to join the network, but the Shardeum blockchain is clever enough to do a consensus check. So every 60 seconds, the Shardeum blockchain maintains a cycle that what is the network demand? What's the actual network demand right now that can help, that can ensure that all the transactions are going through. So if the network is saying that, hey, like 750 TPS is fine for now, then the Shardeum blockchain is smart enough to bring in the exact amount of validators into the active section and maintain that 750 TPS until the demand changes. It can go up or it can go down. Now, for example, let's assume that suddenly there's a new NFT mint happening on top of the Shardeum blockchain, and that you need more TPS capacity. What the Shardeum blockchain is designed to do is like it will bring in the standby validators from the standby pool into the active section and increase this TPS. So this is how, like, it's dynamic and the auto scaling feature that based upon the number of transactions that the network is currently having, it is smart enough to auto scale up or auto scale down based upon what is the demand in the network. And that's how the linear scalability and the auto scaling feature comes in as the major innovation in case of Shardeum and using the sharding technology. So that's the regarding the auto scaling feature. So these are the overall high level discussion about auto scaling and dynamic state sharding. Obviously, like for auto scaling, you can deep dive into our docs and more on how that each of these scale up or scale down is happening, in how the dynamic state sharding, what's like we are doing dynamic state sharding So how are the states sharded? The blockchain state is always have been a very important topic of discussion. So you can learn more into deep dive into the Shardeum docs, but we will go through that a little bit later also. But yeah, for now, this is the basic overall explanation of those features. Now let's come back to another Shardeum feature, atomic composability. So in this case, like in this slide, you will get to see how from your wallet a transaction is happening and submitted to the Shardeum blockchain. And I know many of you must be having that question that if the blockchain is sharded, then like can I access the data from one shard into another? How are those linked? Do I need to care about that? So this is exactly what we will go through in this slide. So this is your wallet, like MetaMask wallet or any other Web3 wallet. And that wallet you're using to interact with the front-end application of any Web3 DApp. Okay, so you're signing the transaction or something, or you're making a swap. So you're using the UI of a Web3 DApp and using your wallet to sign those transactions and all. Now, Shardeum has a feature called Automated Access List, EIP 2930, in which, like the exact point of, if you're wondering that if my data, if my application lives, for example, in shard A, then and if the user address is tracked by shard B and C, how will that user interact with my application? Because those are shards, right? Those are separate entity. I just said that those are separate entity. That's where the atomic composability feature comes in. Atomic composability means that those shards are interlinked with each other, and like your data you can access from one shard to another. It doesn't matter in which shard or which your data lives in. Your app data, like your Web3 like application data, or the user, which shard the user, which are the shards that are being accessed by the user, it doesn't matter. That comes with the atomic composability feature, that no matter where your application lives in, or no matter what are the shards your user wallets is being tracked from, the communication will happen automatically under the hood. So with that is achieved from the EIP automated access list. So whenever a user makes, for example, I make a transaction of swapping A tokens with swapping B tokens, and the A tokens lives in one shard and the B tokens lives in another shard. Whenever you submit the transaction, this access list will have a list of all the wallet addresses, including the like the router of the swap, or the A token and the B token, and it will automatically gather all the data and make the transaction successful without even the developer or the user need to worry that where their application lives on or which shard their application lives on. That is a cool feature of atomic composability on Shardeum. And this happens automatically in unsharded networks, but with sharded network, this becomes a problem. And with atomic composability, we are able to overcome that problem. And then from the automated access list, it's submitted to the RPC node of the Shardeum, or RPC node of any Shardeum node, RPC URL of any Shardeum node, and that's submitted to the any given node, and it's clubbed together into a shard, and the multiple of those shards combined together to form Shardeum. So these are individual shards. So that is the overall life cycle of a transaction, and how atomic composability helps and abstracts that need that you don't need to worry about in which shard your application data is. It will all happen under the hood automatically. Also, like I think one thing which I definitely would like to cover also is that EVM based. Shardeum is Ethereum virtual machine based layer 1. So you can write your smart contracts in Solidity. So I know, like if you're in Web3 or if you're starting Web3, the first smart contract language you stumble upon is Solidity. It's much more ideal to JavaScript developers and like initial beginners. So it's totally EVM compatible. You can start writing your Solidity code, and we are going to discuss a little bit more about that. But yeah, this is all about atomic composability, and next, let's go to the why like you guys should consider developing on top of Shardeum. As I mentioned, that this is the list of features of Shardeum and how like you can build scalable tabs on top of Shardeum. The auto scaling features, Shardeum auto scales autonomously, which I just explained. It's EVM based. EVM has the largest ecosystem of Web3 developers, so you can easily deploy your application on top of Shardeum. If it's already on other chain, it's very easy to ship to Shardeum. You just need to deploy your smart contracts again, change the RPC node, and that's it. You're all good. Its atomic composability is maintained. Like existing sharded blockchains don't have atomic composability, so that's one of the innovation Shardeum brings to the table. Users like one of the biggest metric which we are proud of is that even with our AlphaNet testnet, like Shardeum is right now in its AlphaNet stage, and on 2nd February we will launch our BetaNet. But even in our early stages of testnets, we have gathered a lot of users and like early adopters, or like early dApps being deployed on top of Shardeum has have blown up, and users have been, because of our community events and having such a large community based out of like obviously native to India. Like we have a very big user base who are already interacting on the Shardeum blockchain. So this can be an opportunity to grab that user base and for your own application which you build. So yeah, that's the users part. And yeah, as I mentioned, Shardeum is native to India. It's the first L1 which is built from testnet by the community, and that is exactly why we are excited for more of you to join to this evolution of the Shardeum blockchain. With that, I think let's get to our docs, but I think there was some questions previously shared in the chat. Question, will we learn how to deploy a contract on Shardeum network? Yeah, we will definitely. That is exactly what we are going to do next. So this is what I wanted to do first, like give you a brief introduction on top of like about what is Shardeum, and now get into the deep dive into how we can deploy on top of Shardeum. I hope my this screen is visible, right? I think all the tabs are visible, right? If not, let me know and I can make that change happen.
Yep, all are visible.
Awesome. So yeah, let's get started on now that we understand a little bit about how sharding is as a technology, how it plays into Shardeum, what are the features of Shardeum. Let's get started into like how you can start deploying your dApps on top of Shardeum. So the number one thing you need to do is download any Web3 wallet. It can be MetaMask for now, and go to the docs.shardeum.org. This is the website link for our documentation, and you can go to MetaMask and add Shardeum network, and from here like you can add all the details to your custom MetaMask network about the Shardeum Explorer. Or yeah once that is done, like once you have added Shardeum network to your wallet, Shardeum is still at its testnet, as I said. And for interacting with the dApps or submitting transaction to any blockchain, you need to pay gas. Gas fee is basically the fee which is utilized to incentivize the node runners, the people who are actively like running a node cost money. So that we can incentivize them. That is how gas fees are paid. So in testnet stage, you need testnet tokens, which you can claim from the Shardeum faucet. So yeah, you can join our Discord server. Like this is the web page documentation page for the Shardeum faucet. You can join our Discord server, and there you can put your MetaMask wallet address, and SHM tokens can be claimed. Or you can go to chain drop and our Shardeum own faucets for the same. So here you can tweet out your so if you click on tweet now, like you will have like a text will be copied, and that you can tweet it out from your own account, and like replace the wallet addresses here with your own wallet and paste the link here, and you will receive 100 SHM testnet tokens in your wallet. Or you can also use like chain drop for this and put your wallet address, and you can receive the SHM token. So once you have the Shardeum SHM testnet tokens, The next thing you need to do is make a smart contract. So as I said, Solidity is the EVM compatible language and one of the most popular language in Web3 build smart contracts. And it's an object-oriented high-level language. It's again designed to target the Ethereum virtual machine. It's the compiler, you can say, and then the distributed compiler. Each of the nodes have their own share of that, run their own version of that, and they compile the contracts and distribute it to the network. So the syntax is much more similar to C++, Python, JavaScript, and we are going to see next on how we can write one and deploy on top of Shardeum. But yeah, that's basically it. So the steps are claim 100 SHM tokens and first add your Shardeum network, claim SHM tokens, and then you can go ahead and deploy your smart contracts. One also important and cool part is, like, if you don't want to manually add the Shardeum network, we have recently created click to connect to Liberty2.x network, and you can just click on this app and like your MetaMask pop-up will come. For me, it's not coming because I'm already the Shardeum network is already configured with my MetaMask. But yeah, you can click to that. You can just click that button and that can automatically be added to your network. So yeah. And Liberty2.x, you are seeing that there are two versions. So Liberty2.x is the most recent testnet version, and this is the one you should be using while you're building your application in this hackathon. And again, like, I think even during the period of this hackathon, the cool thing is, by the time you're going to end this hackathon, or you're going to build your DApp, our alpha net, our beta net will also be live. So once those are live, you can shift to that too. But for now, until the beta net is live, you can still build on Liberty2.x. So both will be considered if you're building on Liberty2.x or in our beta net, like any of those, like if you're building for this hackathon, will be considered. So all well and good on that. So as I said, yeah, this is the Solidity part. You write smart contracts on top of Solidity. And let's just get to Remix. Like if you go to Remix or Ethereum.org, it's a online ID to quickly run and iterate your smart contracts. I have built out a very basic smart contract. If you can see, like, first you need to declare the Solidity version. Then this is the structure of a smart contract. You say contract, the contract name. We are declaring a variable string called mood. Then this is a very basic. Whenever you learn a new programming language, get a setter function and a getter function. The set function sets the mood to the local mood variable, and the get function just returns the mood, which is being set by the set functions. So this is a very basic structure of a Solidity smart contract. Solidity smart contracts end with the .sol like file name, and that's a way to represent the Solidity smart contract. And you can go through the unique Remix IDE to quickly iterate your smart contracts. So let's just quickly get and deploy our first smart contract on top of Shardeum. So right now you can see the environment is Remix VM. So instead of that, let's change to injected provider MetaMask. And yeah, now you can see, like, as I previously mentioned, I'm already connected with the Shardeum Liberty2.x network. So, and I've already claimed some SHM token for me. So I have 14 SHM tokens. This is testnet. So even you can see here also, it's saying 14 Ether. Like, Remix is initially like built by the Ethereum Foundation team. So all the units are in Ether, but it's actually 14 SHM. So, and you can see, like, once if you have followed the previous steps and configured your MetaMask wallet correctly with all these details with Liberty2.x, or you have clicked on this button, you should be able to see the custom 88A1 network. So 88A1 is the network chain ID of Shardeum Liberty2.x. So if you're able to see that, then you're correctly configured to the network. And so yeah, let's just go and compile this smart contract. It's compiled. We are not seeing any errors, and we are already connected to the Shardeum testnet. And let's click on deploy. You can see creation of mood diary pending. The MetaMask pop-up came up, and it's saying to pay 0.2415 SHM, and we're going to confirm that. And soon you are going to see that the transaction has been validated in the Shardeum network. Till the transaction is happening, let's just go to the Explorer. So Explorer is something where you can go and see the status of your transactions. And yeah, that's it. You can see the transaction has been successfully created. This is the transaction. It's been successfully created. This is the transaction hash. Let's just copy it. Let's go to the Shardeum Explorer and paste it here. And you can see it's a success. So this is the transaction hash. It was created in a few whiles ago, a few seconds ago, and this is the contract address, and this is the wallet address in which it was created. So yeah, that's it. That's pretty much it. So if you have already an EVM compatible smart contract, if you have already written a smart contract in Solidity, the only thing you need to change, as I mentioned, is change the, where did it go? Okay. Change the endpoints. Yeah. Change the endpoints and deploy on top of Shardeum. That's pretty much it on how you can deploy your DApp on top of Shardeum. And yeah, I think that's basically it on for the demonstration purpose. Obviously, like, you can build, like, the Shardeum ecosystem is still at its earliest stage, and as I said, like, we are just going from AlphaNet to BetaNet stage. You can build typically like any type of application, and that can add to the Shardeum ecosystem. There's a lot of opportunity. As I said, there's a lot of users already. You already saw that how easy it's to deploy on top of Shardeum. This is for the low, online IDE to build out full stack application. Also, you can say decentralized application. You can use something like Hardhat. Hardhat is a much more like a end-to-end framework which you can use in your common what do you say VS Code and all. So you can just install Hardhat, and the documentation is also pretty straightforward. Go ahead and install Hardhat, and you can see a step-by-step tutorial on how you can write and compile your tests on top of Hardhat. And again, the same thing. While you're going to deploy on a live network, while you're going through that, instead of the URL, you will put the Shardeum RPC URL, which is the new RPC URL, and your private key will be in your. You can follow the steps over here, and that should be pretty much be very similar to that. And the only thing you need to change is the RPC URL, and that's it. You are good to go. And with the benefit of using Hardhat will be that when you are building full stack application, the connection between your front end and your back end, like, that's where Hardhat will be much more useful instead of just Remix. Remix is something which you can use to quickly iterate through your transaction, like smart contract logic, and see the errors and all, and just quickly check the methods. So for example, one thing which we didn't do is like check whether our program even works. So we deployed and I showed you that it's a success. But what does this smart contract do? It sets the mood of as I said, it's a string, a variable called mood, and there's a setup function and a getter function. So let's just set the mood that we are happy after this workshop. Hopefully you all will be happy after this workshop. So let's just call, by clicking on this button, we are just executing the function. And you can see this is a write function. So we are writing on top of blockchain. Every time you write or change the state of a blockchain, you need to pay the gas fees, hence the transaction fees. So now you can see the transact to mood diary.set mood is pending. The transaction is still it's still being active, and now the transaction is accepted and it's included. So we can see the transaction was successful. These are all the data. Again, we can check the transaction hash on the Shardeum Explorer. But now we have written on the Shardeum blockchain. So we have written the string happy on top of the Shardeum blockchain with this application. Now we have another function called getMood. Now getMood is a read function. The simple concept is that whenever you are writing to a function, you need to pay gas fees. But whenever you are reading from a smart contract, reading doesn't cost any gas fee. So when I click on get mood, I will receive happy. Now you can see that the Remix IDE internally made a call to the blockchain and checked what is get mood returning. And when it did, you would notice that I didn't have to do any MetaMask transaction, and I got back my string happy. So that's the cool thing about blockchain. Like, you can read the blockchain 99 million times and you still won't need to pay any gas fees. You only pay gas fees whenever you are changing the state of the blockchain. The blockchain has its own state. Is if it's A plus B plus C and you want to do A plus B minus C, that's only that time you're paying the gas fees and changing the state of the blockchain. So that's a very overall basic demonstration on deploying on top of Shardeum and the different aspects of it. Obviously, as I mentioned previously, you can learn more into the terms about auto scaling, the dynamic state sharding onto the introduction tab. What is sharding? What is Shardeum? How the transaction consensus happens, the Liberty opcode. So basically, what EVM does is you write the contract in Solidity smart contract, like Solidity language. You write your smart contract in Solidity, and the EVM is responsible to take that smart contract and change into specific opcodes. So these are some of the opcodes which like Shardeum supports, and it's basically converting that into machine readable format so that the EVM can execute the logic. And yeah, like you can read more about the smart contracts and how you can deploy it. I already showed with the Remix IDE. You can check we have a hard hat section also with the entire hard hat on how you can import those and deploy through hard hat. And yeah, like the tokens, there are ERC20, ERC721. You can deploy different types of tokens. And that's basically, I think, it for our workshop. And yeah, I think if there are any other questions, I would be happy to answer. For this hackathon, we have $500 in prizes. So you can literally build anything, like starting from NFT marketplaces, payment applications, DeFi applications. You can even go and check other ecosystems. What are the most widely used applications, or what are the applications which are not able to perform as they should because of transaction limits? And you can build those similar kind of applications on top of Shardeum without those limits, because it's auto scaling. We have much higher TPS capacity than other blockchains. So you can build those kind of applications into your projects, and I'm looking forward to see what comes out of this hackathon. And we are always ready to support new ecosystem projects which are coming out of hackathons, and we will soon be launching our ecosystem grants fund also, so you can probably start a company out of it. So there's a lot of opportunity right now on building on top of Shardeum. So it's on you guys on how you can leverage that for your own. And yeah, I think that concludes my session. If there are any other questions, I'm happy to answer.
Thank you, Sandeepan, for the awesome workshop. So as I see, there are no questions for now, so can move forward. So you've been in the Discord, right?
Yeah, I'm in Discord.
Cool. So if you guys have any questions regarding the Shardeum, you can ping Sandeepan on Discord, or we had a separate channel for Shardeum itself. You can ask any questions you had on Shardeum. So thank you guys for joining this workshop.